Hello and welcome back to the course on computer vision. In today's tutorial, we'll talk about the idea behind GANs. GANs were invented by Ian Goodfellow, or to be entirely correct, by Dr. Ian Goodfellow, who currently works at OpenAI as a researcher. And he's only 31 years old, but he actually created GANs even earlier. So when he was in his late 20s, a couple of years ago, he created GANs. And the story goes that he finished off the idea for GANs when he was at a bar. I don't know if that's true or not, but you can definitely check out about more of that online. But it's a crazy story anyway. How at such a young age he's brought something to the world that is really drastically changing this whole field of neural networks and computer vision. And so, what are GANs? The abbreviation GAN stands for Generative Adversarial Network. And we're going to talk more about what GANs are and how they're structured, how they're trained, what they're used for in the further tutorials in this section. But today I just want to talk about the philosophy. Why were they created in the first place? Well, the reason why GANs were constructed is because neural networks are generally good at predicting things or classifying things and solving problems. But we wanted to create, or I guess better to say that AI researchers wanted to create a type of neural network which can create for itself. And that's why they came up with this idea of generative adversarial networks. So GANs can actually generate images. They can create images of, or like kind of photos of things that never actually ever existed before. So they learn about the world, they learn about our objects that we have, that we use, or animals or anything, and then they can create new versions of those objects that actually never walked this planet, or these objects never existed, were never built by humans, but they can create images of those objects. So they can actually, you can think about it as they can have an imagination. And the way that GANs work is they have two components. They have a generator and a discriminator. And these two components are constantly in touch. The generator generates images, and the discriminator then assesses those images and tells the generator whether or not those images are likely to be similar, or are similar to what it has actually seen in the real world that it already exists. So it's got these two components that work in tandem. And when you're training, this is the interesting part, and this is like a very philosophical part. We'll definitely go into the detail about how the generator works, how the discriminator works, how they connect it, and so on. But what we need to understand is the philosophical concept that when you're creating a generative adversarial network, when you're training it up, you are bringing these two up together from scratch. So it's not like you have, and this is the part which I needed to get my head around when I was learning about them, is that you're not just creating, it's not like you have a discriminator that already knows everything about the world, and then this generator is generating things, and the discriminator can right away tell the generator if that is, that looks like a real object or not. No. The fact is that they start from scratch, from zero, and then they learn together. So the generator generates some images. For instance, you're generating, let's say, images of tables. And then the discriminator will look at the images that the generator generated, and it will look at some images of real tables. It will compare the two, and it will learn for itself what is a table and what isn't a table, because it will know, by default, it will know what the generator generates actually doesn't exist. It has that knowledge, and therefore it will know what is a table, what isn't a table, and then it will also give feedback to the generator saying, hey, your tables are not really tables because of this and this and this. I could tell right away. So they're kind of playing a game. Think of it as they're against each other, but they're learning together. So the generator is always trying to create images which look like real tables to fool the discriminator, to trick the discriminator in believing that those are real tables, whereas the discriminator always has actual images of actual real tables to compare to in order to learn better and then also give feedback to the generator. And in that sense, and we'll see exactly the mechanics of this further down, in that sense they learn together, they grow together, and eventually this whole network as a one whole, it learns how to better and better and better create these tables that are indistinguishable from the real world tables. And so even though they're working against each other, they're fighting against each other, as a whole the network is getting better and better and better and more robust. So that's the philosophy behind GANs, that they are designed to create objects or images, to be entirely correct, images of objects, animals, or even humans, based on what we have in the real world. So you can think of it as a generative adversarial network is actually learning about our world and then creating objects or creating images of objects which actually are very similar to what we have in our world but never actually existed. So yeah, that's I hope that sounds exciting. We're going to dive into that in the upcoming tutorials. And for now, if you'd like some additional reading, there's a great blog post by Chanchana Sornsutorn. I hope I pronounced that right. It's on Hacker Noon. You can check it out there. I've got a link. Basically, it will talk you through the intuition behind GANs. We're going to discuss all of this in the upcoming tutorials, but in case you wanted to prepare, in case you wanted to do some pre-reading so that you're, you have an additional point of view, then you can check out some extra insights over there. But again, we'll definitely discuss all of this in upcoming tutorials, and I can't wait to see you there. And until next time, enjoy computer vision.